Hello everyone, welcome to the fourth edition of the Lunch and Learn session, organized by the SPE Brazil Flow Assurance Technical Committee. Today the event will be held in English and our speakers will discuss about applying composite coiled tubing for platform-based remediation of flow assurance deposits in subsea risers and flowlines. My name is Maria and I'm part of the board of directors of the Flow Assurance Technical Committee. First, I would like to invite those who are not members of our community yet to become part of it. You may point your cell phone camera on the QR code that's been presented in the screen to join our community. As well, you may also contact us through the email that's been displayed at the bottom of the screen. Our objective is to disseminate knowledge in the area of flow assurance to the promotion of events, publications, seminars, and other means of scientific and technological communication. This is the agenda of the current year. So this year we have held 3 lunch and learn sessions, one in June, the other one in October, and this one that we are gonna be presenting today. And we had 2 other events on August 2025 about wax deposition and the other one about emotions on September. So I'm so happy to make this announcement. This week, our committee was awarded in 2 categories on the SPE Brazil Award event. First, our committee was awarded in the category of Cutting Edge Initiative due to our event called Hackathon, which it is organized in partnership with the ESSS. On behalf of our board of directors, I'd like to thank our volunteers who take their time to make this possible. In addition, our chair, Tiago Silva, was awarded by his technical and professional excellence in the category Production and Operation. Tiago, congratulations on your achievement. You deserve it. We are so proud to have you as a chair. So, speaking on Tiago, I would like to invite him to the stand. So, Tiago will be our chairperson today. So, as a specialist in flow assurance, artificial lift, and multi-phase flow in Petrobras since 2006, Tiago has served as department manager for research, development, and innovation in flow assurance and artificial lift at Petrobras Research Center. He holds 6 patents filed by Petrobras and has published several technical papers in national and international journals. He is also a professor in the postgraduate program in process engineering at PUC Minas, and currently is the chair of the SPE Brazil Flow Assurance Technical Committee. Tiago, thank you and welcome to the stand, and thank you on your award.
Thank you, Maria. Thank you for the congrats too. It's a pleasure to be here again. Welcome everybody for the 4th edition of Lunch and Learn. Today, it's I'm very honored to be the chairperson of my friend Kevin Cole. I will read his mini bio. Kevin Cole is VP of Commercial for Paradigm's Flow Service Business based in Houston since 2016. He has led the commercialization of Paradigm's FlexiCoil technology, including its diversification from its core application of remediation of solid deposits in risers and flow lines into providing a low-cost retrofit artificial lift solution to improve recovery from deep water subsea wells, for which he is patent pending. So today, Kevin will present and will talk with us about applying composite coiled tubing for platform-based remediation of flow assurance deposits in subsea risers and flow lines. Thank you again for accepting invitation, Kevin. So after your presentation, we will have some time to questions and answers. Okay, thank you again. The stage is yours.
Thank you, Tiago, and good morning, everyone. I really appreciate everybody taking the time out of your busy days to come and join the presentation. I'd also like to thank Tiago and the Flow Assurance Technical Committee for their invitation to present to you all and for their continued voluntary efforts to advance discussion in this field of flow assurance. So if you haven't heard of Paradigm before, if you haven't encountered us, then I can tell you that we are a group of companies that are headquartered in the Netherlands with overseas bases in Aberdeen, Scotland, and in Houston, Texas. And the common theme across the group is that we have developed and commercialized quite unique technologies to address what are often niche problems within our various disciplines, which also include drilling and well intervention. But the subsidiary that I work for, Paradigm Flow Services, we deliver what we feel are unparalleled production solutions to the deep water sector. And they're usually underpinned by what is our flagship technology called FlexiCoil. And that's what we're going to discuss in more detail in the presentation today. So that brings me to the topic, and you'll notice that I haven't used the brand name here. We're titling it Applying Composite Coiled Tubing for Remediation of Flow Assurance Deposits in Subsea Risers and Flowlines. And I don't need to tell you guys that flow assurance in deep water production is a pretty challenging discipline. One of the reasons that is that it sits at the convergence of many other technical domains. So reservoir, subsurface, subsea, production, process, and it relies really quite heavily on high quality inputs from each of these disciplines. Flow assurance risks also tend to be fairly catastrophic. Many disciplines deal with continued degradation. So for example, if you have a reservoir that underperforms, then you can expect lower rates. If you have higher water cuts, then you're going to have increased OPEX to manage water. But if we form, for example, a hydrate in a flow line, then we have a complete production shut-in. And in some fields, like the pre-salt, for example, where you might have flow lines that are producing 50,000 barrels per day, that equates to about $3 million per day in lost revenue in the event of a hydrate blockage. So the CEO is going to be calling you pretty soon in that eventuality. So I think it's worth considering some of the secular trends that are at play here when we frame this challenge. And a lot of these were actually discussed at the SPE Subsea Symposium event, which I attended last week in Rio. We all know we're moving or probably have moved into ultra deep waters where we have ambient temperatures as low as 2.5 degrees Celsius, extreme hydrostatic pressures. And the industry wants to install ever longer tiebacks to try and tap into some of the marginal fields that are around existing production facilities. So there's obviously a strong economic incentive to do that. A good example in Brazil is Prio's Wahoo tieback, which is about 30 kilometers back to FPSO Frade. So that obviously increases cool down time of the production stream, further exacerbates the flow assurance challenges that we face. But these challenges, they're really compounded by the fact that we're also producing now from very high pressure and temperature reservoirs. There are multiple 15,000 PSI developments now in the Gulf of America, including Shell's Appomattox development, which actually flows at about 175 degrees Celsius, so very hot fluids. And finally, I kind of already mentioned it, but the economic and financial pressures that the industry has been operating under since probably about 2015, since the downturn, they've really brought about an increased focus on capital discipline. So we're seeing operators do things like pushing the envelope with more minimalistic system designs. A good example of this is single versus dual flow line tiebacks. And these are engineered and installed also under quite compressed delivery schedules. And sometimes that can mean compromising on specification of the system. So I know of many new developments where, for example, they may be using an 8-inch instead of a more optimal 6-inch flow line, purely to try and accelerate delivery because of availability constraints. So there are challenges aplenty, and I think there's an acceptance that the requirement for intervention to remediate solids deposits is somewhat inevitable. But the problem here is that there are relatively few proven technical solutions to these challenges, and that these are mostly depending on using DP2 or DP3 class intervention vessels. And the cost of these is fairly significant. Sometimes it can be in excess of $400,000 per day, and that's on top of mobilization and demobilization costs in the region of $1 to $3 million, so very expensive. Added to that, in Brazil and the Gulf of America, the spot market for these type of vessels is really quite tight. Many vessels have been repositioned over the last few years into the renewable sector, so we're competing for less and less vessels of opportunity. And this is a particular disadvantage to the smaller operators that are operating perhaps mid and late life fields. Further, the duration of vessel-led remediations is also inherently quite unpredictable. Factors such as weather can really affect how long it might take to, for example, remediate a hydrate blockage. So that makes budgeting and cost control even more challenging. And so this brings us to FlexiCoil, which is a platform-based solution that we believe can reduce vessel dependency and resolve many of the problems that we've highlighted already. And we describe FlexiCoil, I think the best way to describe it is as a miniaturized flexible coiled tubing system that resolves what are often fairly complex riser and flowline intervention applications. And the complexity is really around the logistics of executing these projects, less than about the work that we're performing. But the two key applications that we have with FlexiCoil are either to re-establish or enhance production, where you have some kind of flow assurance deposit that is constraining it. So paraffin wax, sand, asphaltene, and of course hydrate. And then the other application that we're not really going to touch on today is about improved oil recovery. And we can do that through retrofitting permanently inside the riser the FlexiCoil tubing to give you artificial lift. So either in-riser gas lift or just to act as a velocity string. So to reduce the cross-sectional area of the riser and to help boost velocity of the production stream, which can obviously help mitigate certain late life issues that we might have, like slugging, for example. But for the purpose of today's presentation, we'll focus on remediation of solids deposits. So I think it's useful to give an overview of the equipment spread. These are the various FlexiCoil components. The ones to draw your attention to are in the bottom left of the screen here. So here we have a horizontal injector. This is the component that grips our tubing, pushes it into the flow line, riser and flow line, and pulls it back out again. Just ahead of that, we have this dual stripper system. So this is a dual 10K stripper system. This is what seals around the outer diameter of the FlexiCoil tubing and maintains a seal at all times during the operation. And then on the front end here, we have a dual shear seal BOP, also 10,000 PSI rated. The other component that's worth drawing attention to is the reeler system. So we have a maximum of about 2.1 kilometers of our tubing on any single drum. But we have this, as you can see, this drop-in drum type arrangement where we can actually connect multiple lengths of tubing together to scale up our distance capability and our reach. So when we've run 2.1 kilometers into the riser and flowline system, we actually isolate the tubing, we close a valve on the connector, we disconnect it from the reeler system, we remove the old drum, and then we drop in a new drum, connect those two together, equalize, and then we continue running into the line. So the reason that we have that type of configuration rather than just one very large reel with maybe 5 or 6 kilometers of tubing on it is so that we can keep the footprint as small as possible. And really the height of the reel is the important part, because as you'll see in the next slide, we're often deploying this in between platform decks. So it has to be as compact as possible. Some of the other components here that I won't spend too much time describing, we have the HPU, the hydraulic power unit. We will also have a pumping spread that provides us with up to 2 barrels per minute of flow, maybe 300 liters per minute or so. And we need that at up to 10,000 PSI 24/7. Depending on what kind of solids we're removing from the system, We may also require some filtration, perhaps a shaker system with an integrated gas buster that would deal with multi-phase fluid returns and also any entrained solids as well. So the key feature of FlexiCoil is how versatile we can be with how we actually deploy it on the production facility. So we actually work around the space constraints on the facility and any weight limitations that it may have too. And we've actually never found, we've never not found a way rather to rig up this spread on any manned production facility. There's always been a configuration that has worked. And the reason for that is just because we can be very adaptable with how we lay out the various components on the facility. And that's because we don't need direct vertical access into the riser. So conventional technologies, for example, like steel coiled tubing, FlexiTubo, they typically require you to have direct vertical access into the riser because the steel tubing itself cannot go through any bends prior to entering the riser. So it limits where you can position the equipment spread. Normally with conventional coil, you may have to rig it up on the riser balcony, which is extremely challenging in terms of crane coverage and just general space constraints there. And then if you have a turret moored FPSO, it could be completely impossible, irrespective of space constraints, to get access to where the riser is. So we can see some examples of how FlexiCoil solves that logistical challenge in both of these photos. So in the left-hand image, you can see the reel in the foreground here, the tubing then running through the injector and the stripper and BOP. And then on the very front end of this image, you will see a grey spool piece that runs from the FlexiCoil BOP all the way into the center of this facility where it tied into an oil export pipeline. So that's quite an important part of the engineering of any FlexiCoil application. We need to know where the FlexiCoil hardware is positioned in relation to the tie-in point in the production piping. And then we need to design and manufacture a conduit that connects us from FlexiCoil to that tie-in point. So that's what you can see in that image. Another good example is this laydown on a turret moored FPSO. This is actually from an application we did in Brazil. You can see the reel on the top deck. You can perhaps vaguely see the red tubing running over this roller guide. It then reorients the tubing down through 2 decks, through another roller guide into the injector, stripper and BOP, and then into the production piping through the turret and then down the riser and into the flow line. So it just shows the adaptability of how we lay out the equipment on various types of production facility. So the enabling part of this technology is probably the FlexiCoil tubing itself. So our standard tubing is a 2.375 inch, 2 3/8 inch OD product with 1.2 inch ID. It's specifically been designed and developed for riser and flow line intervention applications. It's 10,000 PSI maximum working pressure. And the two key features are that it's extremely lightweight. So if we are pumping any fluid or any liquid that has a density similar to that of seawater, the tubing will actually be neutrally buoyant in the flow line. So instead of being under buoyant, being heavy and sitting in the bottom of the flow line, or being over buoyant and floating to the top, it sits in the middle. And that minimizes contact points. It minimizes drag, frictional drag, and that is what allows us to maximize our reach into the flow line. So that's a very important feature. The other is that it's highly flexible. It has a minimum bend radius of around about 30 inches. So that means that we can run through up to 1,000 degrees of surface piping bends, hard piping bends, as long as their radius is 30 inch or above. So 6 inch 5D piping, for example, is navigable with FlexiCoil. It's also compatible with all production fluids and standard oil field production chemicals. And another key point to mention is that it's soft. It's an HDPE outer layer, so it's quite soft, and it won't cause any abrasive wear to the inner wall of your pipe. So there's no concerns with any potential impact on the integrity of the surface piping, the riser, or the flow line itself. So we have a couple of applications that we think would be of interest to share with you guys. The first is on FPSO Forte P50 in Brazil. And it's obviously an older facility, and some of the wells, most of them actually are in either mid or late life. So they're seeing very high water cuts, which is obviously causing issues with hydrate formation in particular. So these wells and the FPSO are in approximately 1,240 meters of water depth. And the client had 3 tiebacks in particular, 3 flow lines where they had formed hydrates that was preventing production. So the first part of the FlexiCoil solution is that we need to perform a site visit so that we can understand where we position the equipment on the production facility, as I mentioned before. We also need to design the tie-in spool that connects us from FlexiCoil into the surface production piping. But part of this visit was to actually locate the blockage itself. So we wanted to make sure that it was within reach of FlexiCoil and just to have some additional diagnostic data. So we actually applied our find block technology, which I'm not going to discuss in depth today, but I can tell you is a very low-cost, simple, non-intrusive technology for accurately locating blockages in flow line systems by using a hydraulic TDR type technique. We create a pressure wave in the system, and because we can record and we know the wave speed of that pressure wave as it travels through the fluid medium, and we know the time that it took to reflect from the blockage, we can calculate the distance to that blockage. So we did that in 2 out of 3 of these flow lines, in the 44 well and in the 78 well, and we located the blockages at just under 4.5 kilometers and just over 1 kilometer respectively. So both well within reach of FlexiCoil. The most complex surface piping configuration was with about 642 degrees of pipe bends, so about 7 90-degree bends or so before we actually get into the riser. And the actual remedial method was just pumping seawater at high pressure. So we were pumping seawater through the FlexiCoil tubing and using it to jet at high pressure the hydrate blockage from the walls of the pipe. So the inlet temperature of that seawater was around 27 degrees Celsius. We were seeing about 18 Celsius on the return side. So that slightly warm water delivered at high pressure to the hydrate was enough to adequately melt it and to break through the hydrates in each of these 3 flow lines. And actually across all 3 flow lines, we only consumed about 21 cubes of MEG. We would pump some MEG pills as we broke through various hydrates in the line. Sometimes there were multiple hydrates in each flow line. We would circulate some MEG after each. But by and large, it was purely just pumping of seawater. And this was actually a very efficient operation in terms of the time that it took to clean through each of these hydrates. It ranged from just over 2 days in the Albacora Leste 84 flow line to just under 4 days, or just over 4 days rather, on the 78 flow line. So really quite an efficient operation, which is very important when we mentioned previously the time that it can often take for subsea vessel-led interventions. So all 3 flow lines were successfully remediated in this application. We restored about 10,000 barrels per day. We did have one interesting lesson learned here, which is that when we were adding additional lengths of tubing, doing the drum swaps, and we lose circulation through the tubing, we were actually beginning to see, when we started to repressurize the tubing, hydrate formation in the nozzles. So that was obviously, it could potentially have been a much worse issue. It was quite easily resolved just by pulling back into the flow line towards the riser. The hydrates in the nozzle dissociated. We were able to flow through them again. But obviously, it could have been a much more challenging scenario. So we updated our procedures for hydrate remediation in this fashion to dictate that once we're doing a drum change out or adding a length of tubing, we actually have to inhibit the system. So we will pump a pill of MEG or methanol around the jetting nozzle to ensure that there is no potential for hydrate formation. So a really valuable application, and I think a good introduction to the Brazilian market for our capabilities in hydrate remediation. Another project that may be of interest is one that we completed in the Gulf of America a couple of years ago. This was a national team remediation project in an 8-inch flow line system tied back to the Neptune TLP in about 1,400 meters of water. The blockage was estimated at about 900 meters from the platform. It was believed to be an asphaltene plug, a single asphaltene plug. The usual features in FlexiCoil applications were present. We had about 685 degrees of pipe bends between FlexiCoil and the riser itself that we had to run through. But it was remediated in a similar method. We're pumping high pressure seawater, in this case with periodic solvent pills to try and bring the asphaltene more into solution. But ultimately, we cleaned to about 3,800 meters measured depth in the flow line, removing several tons of asphaltene in the process, and ultimately reinstated about 3,500 barrels of oil per day of production. So again, a very successful demonstration of FlexiCoil. This was the layout on that facility. Again, it's just a good example of how we can be flexible with how we position the equipment. So this is a multi-deck layout at surface. You can see in the image on the left, the reel positioned on this landing deck. In the center image, you will see the roller guide that I mentioned previously that reorients the tubing or takes the tubing down one deck. And then through the injector, stripper, and BOP, again, the item on the right-hand side that you can see here is the control panel. So that's where the operator would position himself and he would control the deployment and the retrieval of the tubing and manage pressures and all the other operating parameters of the campaign. So what about long distance tiebacks? You'll probably have noticed that in the cases that I've presented, our reach was under 5 kilometers in both of these applications. And the reason for that is that FlexiCoil's current reach capability is up to about 6 kilometers, depending on various operating parameters. We have some initiatives to try and increase that reach. So for example, we are actually in the middle of a development program that's being done in conjunction with Shell here in the Gulf of America. And we're developing a tractor technology that we will integrate with our tubing that will give us much greater pull force to pull us much longer distances into the flow line. So we expect that our reach capability will be in excess of 10 kilometers. And we were hoping that that is going to be ready in the second half of 2026 for its first field deployment here in the US. But I'm conscious, we mentioned the Prio Wahoo development at 30 kilometers earlier. That still means that there's a significant portion of many flow lines that will be inaccessible to FlexiCoil from the production facility. So we can deploy FlexiCoil from a vessel subsea through various tie-in points. And I would say that it's very important that to ensure that that is an option, that we have early engagement during feed or pre-feed stages so that we can enable or optimize that kind of intervention. We would need to understand things like where we position access points, inline sleds, for example, at various points through the flow line so that we can access and enter from each of those and ensure that we can cover the flow line in full. So FlexiCoil right now, you could probably say that it's not a silver bullet, as some might say, for solving many of the flow assurance challenges that we're encountered with at the moment. But we do believe that it does and will continue to play a major role here going forward. So thank you very much for listening. I'm glad to take any of your questions. You can also feel free to connect with me on LinkedIn and reach out later if anything springs to mind. But thank you again for listening, and I will hand back to Tiago. Thank you very much.
Thank you, Kevin. It was amazing, especially the cases you brought for us here in Brazil and other places. Thank you again for your because you are available to present for us the FlexiCoil. I think we have some questions here. Let me check. Celso Junior he says, thanks for the presentation, Kevin. ROFOGU, he's questioning, is there a maximum horizontal bend angle beyond which a riser surface inlet performance is compromised? Is a vertical inlet to the riser considered ideal?
So no, actually,
it's from Roberto Fonseca from Wood.
Thanks for the question, Roberto. We can actually have either a direct vertical access to the riser, or we can be offset from it and enter through a bend that will tie us into the riser. So the equipment, the spread that I showed you, the injector, the stripper, and the BOP, it can be rigged up vertically directly on top of the riser. But in the vast majority of the applications we do, it's horizontally configured, like you saw in the various images. I guess the reason for that is we usually just do not have direct vertical access into the riser. And then there's other things to consider, like supporting frames and everything else to actually, if you do have direct vertical access, to rig up on the riser. So we find it easier just to do it horizontally. Sometimes the conduit that connects us from FlexiCoil to the piping, the surface production piping connection, it could be as simple as a single 90-degree bend. Other times we may have 3, 4, 5 separate spool pieces that need to take us perhaps from one deck on the opposite side of the platform to a lower deck on the other side of the platform. So it can be more complex and convoluted. So yes, I think the ideal scenario is to minimize the number of bends, but whether it's a horizontal or vertical rig up is inconsequential to us. We can do both. Thank you.
Okay, thank you. Another question from Roberto. Do you have an example of application in case of scale deposition?
We actually don't. So good question, Roberto. We've done many applications with paraffin, sand, asphaltene hydrate, but we typically don't encounter scale deposition in flow lines very often. We're actually discussing with an operator here in the Gulf of America at the moment an application where they actually have unknown deposits, but they definitely have calcium carbonate scale. That is something that we can address with FlexiCoil. The tubing is compatible with citric acid, for example, so we can pump citric at high pressure, and with seawater, we should be able to jet through that. But with harder scales, like barium sulfate, for example, FlexiCoil is probably not the ideal solution. We probably will not be jetting at a high enough pressure to be able to remove a scale of that hardness.
Okay, thank you again. Celso from Repsol Sinopec, Brazil. The remediation in this case in Brazil was high pressure jetting. What other type of remediation could be applied using CT, using the FlexiCoil, right?
So one of the differences with FlexiCoil and conventional steel coil tubing, or FlexiTubo, is that we cannot handle reactive torque. So that we don't have the rigidity in our tubing to be able to handle reactive torque. So things like milling tools that you maybe use with FlexiTubo in downhole applications, we cannot run them with FlexiCoil. We can pump gas, so I guess an alternative remedial solution for hydrate remediation, if we consider an example where maybe the hydrate is at 9 kilometers and perhaps we can't reach it with FlexiCoil to jet it with seawater, the alternative solution would be that we would gas lift the riser and reduce the hydrostatic pressure to encourage dissociation of the hydrate. So really it's only fluid conveyance that we have with FlexiCoil. We can pump a liquid, we can pump a gas, but no mechanical feeding method is possible.
Okay, I think it's clear. No mechanical strategies, but you can pump a large number of liquids and chemicals, right? And you can just displace the liquid using nitrogen, for example, right?
Correct.
Or even natural gas.
Yeah, that's
Okay.
correct.
Okay. I think we don't have more questions. So I would like to thank you again, Kevin, for the excellent presentation. And this is very important for us here in this technical committee to share different information for all the professionals in flow assurance. So thank you again, and you will be invited again in some time for other updates in FlexiCoil. Thank you again.
Thank you, Tiago. Thank you, everybody.
See you.